Dr. Tanmoy Biswas, I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about catechol. Catechol means 1,2-dihydroxybenzene. So actually 3-step of reaction is carried out on this catechol moiety, and you have to say what is the major product of this reaction. Students, actually this problem is little different and difficult, I agree. But still I request you, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. And don't worry, after some time you'll get the right answer. I believe you have tried by yourself, so it's my turn to give you the right answer. But before going to details, as usual, I suggest you student, the catechol moiety is easier. Actually it's an electron rich aromatic moiety, and it's you should look at the reagents. First step reagent is PCl3. Student, a very important concept about this molecule PCl3 is that this phosphorus has 3 bonds with chlorine, and these phosphorus chlorine bonds are sigma bond and not that much stable. Point number 1. And remember, phosphorus has a special affinity attraction for oxygen because of, first of all, sigma bonding, additionally back bonding. So that's why if there is any OH group present and you allow it to react with phosphorus trichloride, it will definitely react. And by the way, I guess many of you have seen that is conversion of alcohol to alkyl chloride using PCl3, PCl5, etc. phosphorus reagents. So based on this concept, let's start. So here if you look at 3 phosphorus, and obviously these 2 hydroxyl are in 1,2 fashion, so they can act as chelating. So you can consider that these 2 hydroxyl act as an nucleophile. First one chlorine will be replaced, second step this another will attack and it will replace the both. So in this reaction 2 molecules of HCl will be produced, and these oxygen and these oxygen will form bond with phosphorus, I mean 5-member ring. So you can see it here. But still student, there is an additional phosphorus chlorine bond, and in the second step what is provided in the reagent list? Obviously these long chain 8 electron alcohol, pyridine ether. Now simple. So actually look at this is also alcohol, so this will do the same thing because still 1 chlorine is left, so it will be left. And another thing, during this process obviously 1 molecule of HCl will be produced, H from here and Cl from here. So in order to quench that, there is pyridine as base. Okay, so this is actually phosphate ester, you can consider phosphate oxidation state 3 ester. And obviously this phosphorus still has 1 lone pair, and that is utilized in the next phase, because we know that iodine can act as electrophile, so it could easily be reacted with any nucleophile, and phosphorus center means lone pair is a good nucleophile because of its softness. Sorry, this will not be I2, I made mistake. So these will attack because this is delta plus and delta minus, this polarization it will open, and phosphorus is soft, so it will do this reaction, and in presence of this it will produce 1 I attached to this iodine attached to phosphorus is plus, and this is an iodine. So these iodine will again react, and here is a 2-type reaction. You can consider that after this backside attack these will open up and go to phosphorus center, and obviously in this case you can think that there will be a double bond formation because this phosphorus was carrying a positive charge, so that positive charge will be neutralized when this bond will go and form a double bond. So in this way it will produce this phosphorus derivative, means obviously I'll say that phosphorus plus 5 oxidation state and this alkyl iodide. So it could be a very good method to convert these phosphorus ester means alcohol into corresponding this alkyl iodide using directly iodine in DCM. I mean you can do it very easily using HI, but if your molecule have other functional group which are HI sensitive, because HI is pretty strong acid, its pK near about -10, so it's a very strong acid. So if you don't want to use it, means if you want to avoid that step, but you want to convert this alcohol to corresponding alkyl iodide, then this method you can use. And by the way student, I suggest you to visit one lecture that is Arbuzov reaction. So similar type of concept you can observe there. So here actually what could be the product? Obviously in this case this option C is one of the product of this reaction. And by the way, if this question is appeared in your exam, how could you solve it? Student, for this question I do not have any shortcut or tricks. I'll only say just follow the basic reaction, alcohol to alkyl chloride conversion by phosphorus trichloride. So you can understand, first 2-chloro chlorine will be substituted by this chelating catechol unit, second these third alcohol, fine, and after if you come up to this, then you can understand that it will be a 5-member ring with phosphorus atom, because the next step is iodine DCM. It's a very milder reagent, it can't do hydrolysis. So based on this much understanding, you can conclude that option B and A gone. Now whether option C or D, for that purpose student, a simple question. Actually after this reaction, it is actually phosphorus acid ester, you can say option number 1 and 2. Iodine can oxidize that ester in, it's true, but this alcohol cannot attack in this way, and there will be phosphorus oxygen double bond, both not possible, because what could be the source of this oxygen and oxidizing agent? No, that's not possible. So that's how option C. I know you'll say that sir, this video is not quite logical, this shortcut approach. I agree student, that's why I told in this case I do not have any tricks or shortcut. This is a little unique reaction, so please try to understand it carefully, and if you have any doubt then watch the video again. Now, so in conclusion, what you have learned today, that phosphorus chlorine bond is relatively reactive, means it's weaker, and phosphorus oxygen bond is very stable due to additional d-pi-p-pi back bonding. What do I mean? Actually, obviously this phosphorus oxygen sigma bond is stronger, but they can also form this d-pi-p-pi back bonding, and p-pi from oxygen, because it has 2 lone pair filled, and phosphorus have energetically accessible vacant d orbital, so they can have a stronger back bonding. So that is actually you may consider another driving force for this reaction. And because of the reactivity of this phosphorus chlorine bond, it finally reacts with alcohol to produce phosphorus ester, because the starting reagent was phosphorus 3 chloride, so that is the final here is phosphorus ester 3 ester. Catechol actually is a chelating cyclizing reagent, and it cyclizes into 5-member ring, and 5-member ring formation is favored because of proper conformational orientation, and it has planarity, and obviously since these 2 hydroxyl are attached to benzene nucleus, it's planar, it's okay, it's possible, and ring strain is somehow little bit relieved, I will say, because the size of phosphorus atom is bigger. Now phosphorus could easily be oxidized from +3 to +5 because it have energetically accessible vacant d orbital, so it can expand its valency from 3 to 5 or oxidation state also, and phosphorus oxygen bond, as I told, it's stronger, so that became facile. And in this context, remember this pi bond is also not that much stable, because if PCl bond is not stable, how pi could be stable? Okay, so it is actually not stable, but it is produced because iodine reacts with the phosphorus lone pair due to its softness, and that's why it could easily be cleaved, this phosphorus iodine bond, by the second row elements like this nitrogen, oxygen, phosphorus, because first of all stronger stigma bond, second thing back donation, because if you look at nitrogen, oxygen and fluorine, everyone has 1 lone pair of electron which could be donated to the phosphorus via back donation. And the last point, iodine is very mild and selective oxidizing agent, and by the way, I have already discussed a dedicated lecture on iodine mediated oxidation. Please visit, it's interesting. So this is the end of discussion. I thank you everyone for watching this video, and if you really enjoy my content and if you consider my channel is worthy, then please help this channel to grow. So stay happy, stay blessed, see you in my next video. Bye bye.